Hi guys, so today we're going to be talking about chemical nomenclature, specifically how to name ionic and covalent compounds. So if you check out my last video, you can learn a little bit more about the characteristics of each bond, but today we're just going to talk about how to write them and how to name them. So first, I think it's important to look at the periodic table and understand the charges of each element and groups of elements. So the cations are going to be on the left, and those are going to be your metals, and on the right, these are going to be anions, and those are your nonmetals. So in ionic compounds, we're forming a metal with a nonmetal, so positive charge with a negative charge. So let's go to the cations. So in group 1, you have your alkali earth metals, and they are always going to be a +1 charge. So then you have your alkaline earth metals, which are always going to be +2. So these charges mean that they are losing 1 electron and 2 electrons, respectively, to form their perfect octet. Okay, so now in groups 3 through 11, these are what are known as the transition metals. And these do not necessarily have specific charges because there can be a multitude of charges for these. Some can be +1, sometimes +2, sometimes 3, 4, even 5. So they are going to give you a Roman numeral when you're writing the formula to signify the charge for these. But there are a few specific ones in this area that have only one charge that you need to make note of. So those are going to be silver, which is always going to be +1. Cadmium is always going to be +2. Zinc is always going to be +2 as well. And aluminum is going to be +3. So if it helps you remember, they kind of make like a little bit of like a stair-step line here. Oops, that was a little messy. Anyway, so if you're looking at it and you're like, oh my gosh, I don't remember what charge is zinc, maybe if you look in that area, you might remember. Okay, so now let's talk about the anions. So the ones we're really going to be using to write ionic compounds are going to be nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine. So those are the ones we're really going to be using mostly. So these are going to be -3, -2, and -1. So 3, 2, 1. So these are what we are going to be using to write ionic compounds. Okay, so let's talk about naming them. So I'll give you a formula. So let's start with, say, calcium and fluorine. So when we're going to name this, we're going to write the name of the metal first. The metal always goes first. The metal goes first in the formula, and the metal goes first in the name. So we're going to write the metal first, and that's going to be calcium. Okay, so now we're going to write the name of the nonmetal after the metal, but instead we're going to take off the ending and add "ide." So this is important. Instead of simply saying calcium fluorine, we're going to say calcium fluoride because it's representing the fluorine ion, not just simply fluorine. Those are two different compounds chemically. Or elements, sorry. So this is going to be calcium fluoride. So the other ones, for example, sulfide, nitride, bromide, chloride, etc. Okay, so now if there's a transition metal, this is what I was, oh, that's fun. If there's a transition metal, that's what I was talking about earlier, we're going to use a Roman numeral to signify the charge. So let's do, for example, Cu2O. So copper oxide, right? But copper what oxide? We don't know what the charge is. So that's why we need to make sure that we use a Roman numeral. So we know that oxygen has a -2 charge, and from this formula we can see that because there's 2 coppers, that the copper charge is going to be +1. So when we're writing this compound, we're going to write the metal first. Well, actually, we're not writing the formula, so we're going to write the name, so copper. But instead, we're going to put a Roman numeral. We're not just simply going to write copper oxide. We need to know what copper. So copper 1 oxide, while making sure to put the "ide" ending on there. Okay, so now we're going to start by writing formulas. So we're going to kind of flip it around. So we're going to start with the name. So let's talk about calcium bromide. Okay, so we're going to identify the symbols and the charges of the elements. So if we're looking at this, we know that we are going to be using Ca, Br, and Ca is going to be +2, and Br is going to be -1. So let's go ahead and write out the charges for the metal and the nonmetal. So we're going to have Ca +2 and Br -1. So just as always, as we wrote in the formula, we're going to write the name of the metal first, or the symbol for the formula. So Ca. And then we're going to write Br, but we're going to crisscross the charges. So this is how this works. Because the Ca is +2 and the Br is -1, we know that we're going to need 2 Brs in order to cancel out the charge of the Ca. So the 2 is going to go to the Br, and the -1 is going to go to the Ca. So when you write the formula, it ends up like this, CaBr2. So it cancels out and it's all even. Okay, and this is the last step. So like if the metal and the non-metal have the same charge, simplify. So what I mean by this, for example, if we have magnesium oxide, Mg plus 2, O minus 2, a lot of people do this. They have the tendency to Mg2O2, okay, done. Well, this is not really necessary. Because they're both the same charge, it's just MgO. Another example would be, let's say, manganese plus 4, sulfur minus 2, sulfide. Anyways, okay. So when we're writing this, a lot of people have the tendency to just say, okay, manganese 2, sulfur 4. But in reality, it's just saying that we need 2 sulfurs to cancel out the positive 4 charge of the manganese. So really the formula would just be manganese sulfur 2, if that makes sense. Okay, so let's do some examples. So magnesium oxide, this is what we talked about earlier. So we're going to use the steps and we're going to write the name of the metal and the charge, and then we're going to write the name of the non-metal and the charge, and then we're going to combine them to form MgO. Remember, these cancel out, not MgO2. Okay, iron 3 sulfide. So they're going to give us the Roman numeral because iron is a transition metal. So we're going to write Fe plus 3 and sulfur, sulfide, minus 2. We're going to crisscross the charges, and we are going to be left with Fe2S3. Okay, these are where the polyatomic ions come in. It is very important for you to know these because they are found commonly in ionic compounds. So when we're writing these, we're simply just going to write the names of the, of the polyatomic ions. So this is going to be simply ammonium phosphate. It's not going to be ammonium phosphide because P-3, the ion for phosphorus, is going to be phosphide. So it's just going to simply be ammonium phosphate. Okay, on this one, cadmium fluoride. So cadmium was one of those ones I talked about that has a specific charge. Do you remember what it is? Right, it's plus 2. So we're going to do our steps and we're going to write Cd, the symbol for cadmium, plus 2, fluoride, minus 1. We're going to crisscross the charges and we're going to be left with CdF2. Okay, silver 2 sulfate. So identifying the polyatomic ions, identifying that this is sulfate, one thing. And silver, this was another one we talked about earlier. Its charge is plus 1. So we're going to write the name of the metal first. Silver. And then we're going to write the name of the polyatomic ion, sulfate. Silver sulfate. All right, lead 2 nitride. So we're going to write the symbol Pb plus 2, nitride N minus 3. We're going to crisscross the charges. And we are going to be left with Pb3 and 2. All right. So now let's go back to the periodic table because we need to talk about covalent compounds now. Binary covalent is a compound between 2 nonmetals. So the important thing in identifying these is making sure that there's not a metal first. If there is a nonmetal that's first in the formula, you know automatically that it's going to be a covalent compound. So the elements that we are going to use in the covalent compounds commonly are going to be carbon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine. So this whole group we're going to use very commonly in covalent compounds. So this is important. So when we're writing covalent compounds, instead of using the charges to signify the subscripts of how many there are, we are going to be using prefixes to identify the number of each atom. So you probably know a lot of these prefixes like mono, di, tri, tetra, penta, etc. Just make sure you know that 1 is not uno or anything like that, and tetra is not quad or anything like that. It's mono, di, tri, tetra, penta, hexa, and so forth, so on and so forth. Okay, so let's start out with naming covalent compounds. So let's say if I give you C2P4. So that is composed of carbon and phosphorus. So we are going to identify the elements from the symbols given. So carbon and phosphorus. Okay, so now based on the subscripts, we're going to write the prefixes for the elements given. Okay, so we're going to start with the first element given in the formula. So that's going to be carbon. And then we're going to have tetraphosphide. It is important to note it is the same rules for ionic compounds in terms of the ide. the second element is going to have an "ide" on the end. So it's not carbon tetraphosphorus, it's carbon tetraphosphide. Okay, so this is important too. Oops, there should be an "I" there. If there's only one of the first element, it does not need a prefix. So this is just like this one. It's not monocarbon tetraphosphide. It's just carbon tetraphosphide. But however, if there's only one of the second element, it needs a prefix. So that is similar to carbon monoxide. You don't say carbon oxide. It's carbon monoxide. Okay, here's another thing. Do not duplicate vowels when naming. So this is something like when you're saying carbon tetraoxide. You don't need to say carbon tetraoxide. You can just say carbon tetroxide. So it's just kind of that thing like listening it and hearing, is there like two vowels in there, tetraoxide? Just say carbon tetroxide. Okay, and last one, if the second name in "I", just like ionics, as I said earlier. All right, so now let's go to covalent formula rules. So this is kind of backwards of what we were just doing. So if I give you the formula, so let's say carbon disulfide. So we are going to identify first that there are two nonmetals present. Okay, there's carbon and sulfur. Check. All right, so now we're going to write the symbols for the elements listed. All right, so C and S. And now we're going to put them together and we're going to write the subscripts based on the prefixes for each element. So C1, we don't need to write 1 there, it's implied, and then sulfur, disulfide. So that's how you're going to write carbon disulfide. Pretty simple. All right, so let's do some examples together. So disulfur pentoxide. Notice how it's not pentaoxide. That's what I'm talking about right there with the vowels. Okay, so disulfur. So we're going to start with the first one they give us, S, 2, O, 5. Pentoxide is 5, di is 2. All right, P4O10. So we're going to identify the elements present. So it's phosphorus and oxygen. So we're going to use our prefixes, and it's going to be tetra, phosphorus, and then decoxide. Excuse my handwriting, I'm sorry, it's getting a little crooked. But notice how we put the "ide" at the end of the second one. Okay, so I'm going to name this as is. Sulfur, that's our first one. And now we have 3 oxygens, so it's going to be trioxide. Sulfur trioxide. All right, dinitrogen tetroxide. Okay, so we're going to have the N with nitrogen first. We're going to have 2 of them. And then we're going to have oxygen, and we're going to have 4 of them. All right, perfect. Now CF4. So we're going to write the name of the first one, carbon. Since there's only one, we don't need to write monocarbon. And then we're going to write tetrafluoride. Keeping it consistent with the "ide" at the end. All right, now here's some extra practice. So if you want to go ahead and pause the video and work these on your own, and then we can check the answers after. All right, so let's see how you did. So we've got manganese, sulfur. So this is one of those, sulfide. This is one of those that I talked about earlier. So we're going to have the Mn plus 4, S minus 2. So then we're going to be left with MnS2. All right, K3N. This is going to be simply potassium nitride. All right, magnesium bromide. It's 2, Br minus 1, so magnesium Br2. All right, nitrogen monoxide. Covalent, remember, recognizing that there is not a metal first. Nitrogen monoxide, just like that. All right, phosphorus pentachloride. Phosphorus, and then we have Cl5. All right, good job. Thanks for watching, and look on my channel for more videos. Thanks so much.